Hello friends, welcome to Shiksharthi. In this video, we'll be talking about quadratic expressions, quadratic equations, and the more focus here would be talking about the nature of the roots. So let's start. So as you would see in our earlier video on quadratic equations, we had talked about all these 7 points. So by now we are already aware of the fact what is the similarity and what is the difference between a quadratic expression and a quadratic equation. So taking the discussion forward from here, wherein we talked about a real root, the maximum number of real roots that I can have for a quadratic equation are 2. And the real roots or real numbers can be basically divided into rational roots and irrational roots. Taking the discussion forward. So can I say that real roots is nothing but a combination of integers and non-integer roots? Of course. Now what are integers? We have already talked about this. If you recall, we had talked about this in my video on fractions. So please refer to my video on fractions wherein we have talked about integers and non-integers and thrown some light on the same. So from here, can I say real roots? Now when I know that the total count of roots is 2, I can divide this as 2 integer roots and 0 non-integer root, or 1 plus 1 or 0 plus 2. Now when I am saying 0 plus 2, I am basically talking about all the 3 cases, but here I am going to discuss this case. Now why am I discussing this case? Which case is this? I am talking about a real root. I mean, you are having 2 real roots of a quadratic equation in which you have 0 integer roots and you have 0 integer roots, which means what? You are having 2 non-integer roots. Now what is the nature of non-integer roots is what I am going to talk about. So I know a non-integer can be broadly divided into 4 parts. Now when I say broadly divided into 4 parts, what do I mean? I mean to say I can have a terminating decimal, for example a fraction like 1 by 2. I can have a recurring decimal, for example a fraction like 1 by 3. Or I can have non-terminating and non-recurring counterparts, non-integers. Now when I say non-integers of the variety which are non-terminating and non-recurring, I am basically talking about irrational numbers. So when I am talking about irrational numbers, I am basically referring to which kind of irrational numbers? Irrational numbers which have a root in it, they are also known as irrational, and those irrational numbers which have a special category, for example pi, e and so on. Right? So here, now when I am having 2 non-integer roots, all I need to understand here is this 2 non-integer roots can be formed out of these 4 categories. Now when I say they can be formed out of these 4 categories are the 4 categories which I have already talked about. One is it can be a terminating decimal or a non-terminating. We are basically talking about non-terminating and non-recurring part, or a recurring decimal, or roots. Roots are known as surds, is what I am talking about. So now taking this point 8 forward, so I can finally say that a real root can also be written as rational plus irrational that we had talked about earlier. So now integers, rational numbers are both integer numbers and non-integers. And what are irrational numbers? They are basically non-terminating and non-recurring decimals. So taking this forward, I can say basically what? When I know that a rational number is formed out of integers and non-integers both, and from irrational numbers you are getting non-integers only, basically. Broadly, you are getting non-integers only. Okay, so now taking this discussion forward is just like the discussion that we were having earlier. So we are having a micro-analysis. And this thinking process is required in mathematics because this helps you to introspect more. You are diving deep into the subject so that you are able to outshine the competition. Now when I say you are able to outshine the competition, I am basically referring to what? You are given any kind of a question, you will be able to solve any kind of a question that is given to you in any testing format if you dive deep when it comes to learning, is what we are trying to do. Okay. So now this broadly can be categorized as real roots will be either integer roots or non-integer roots. Now integer root means what? I can have negative integers, which is a neutral integer, or I can have positive integer roots. So integers can be broadly divided into three parts: negative, 0 and positive. And non-integers can be basically divided into two parts only based on their polarity. One is negative and the other one is positive. In short, these two roots, if a quadratic equation is having two roots, this is the very important part. These two roots need to be at a micro level, need to be divided into 5 parts. What are these 5 parts? Either both the roots would be integers, or both the roots would be terminating decimals or terminating fractions, or both the roots would be recurring decimals, or both the roots would be surds, or both the roots would be special irrational numbers. Now when I say special irrational numbers, I am basically referring to pi and e. I'll take few more examples before I give you a homework for the day. So you would see the time when I was talking about, now this is a discussion only for non-integer roots. That means non-integer roots of a quadratic equation can be divided at micro level into 4 parts. So can I say both the roots would be 1 by 2 and 5 by 2? I'm sorry, 1 by 2 and 1 by 5. Now when I say 1 by 2 and 1 by 5, I am referring to what? Both the roots being terminating decimals. Similarly, if I say both the roots are recurring decimals, which category am I referring to here? I am referring to 1 by 3 and 1 by 7, because 1 by 3 and 1 by 7 are basically those roots, and then those roots which are recurring decimals, and because of this then I am forming an equation also. So what is your homework? Your homework is, first you'll go through all of these cases that we have made. How many cases have we made? We have made 10 cases. And I have given it a slight tinge of permutation combination, especially for those people who can understand. So wherein I know that there are 4 variables and I am supposed to divide 2 such that I am looking for non-negative integer solutions. So when I am looking in for non-negative integer solutions for a sum of 4 variables giving me a sum as 2, what is the answer that I am going to get? 5C3. So I would have got 10 cases. So there were 2 ways of writing these 10 cases. One is the fundamental way of writing, in which I have written all these 10 cases, or I could have guessed that I am going to get those 10 cases with the help of permutation combination. What is permutation combination? Thinking more deeply about the subject. So this you will take it as a homework. Now what is the homework here? You will try and relate which case have we discussed. So if I talk about this case, let's say this case. So here I have one terminating decimal root and one non-terminating and non-recurring root. So I've given it a discussion also here. So when I say this, I'm basically referring to this category. I hope you got it. And based on that, once you're able to find out the roots, these are some cases, these are the roots that I have taken, these are the roots. And based on the roots, I have found the equations. Which equations have I found? Quadratic equations. And which is the formula that I have used for this quadratic equations? A times of x square minus sx plus p is equal to 0, where I have taken the value of a as 1. Or I can take any value of a except for 0. I hope you got it. Last but not the least, now we are going to talk about how many cases can I finally get when I'm looking for the number of roots. Now please recall, we talked about in this session, we are not focusing on the role of delta deciding the nature of roots. We are just talking about the nature of roots, assuming that whether they are real or imaginary. Imaginary we have not talked about, we are only talking about real roots. And then there's segmentation. So can I say, if I have to write down the nature of roots based on their polarity? As of now, we were talking about the nature of roots based on numbers. Rational numbers, irrational numbers, integers, non-integers. Now we are going to talk about the nature of roots based on their polarities. So can I say 2 negative roots? I'm talking about there are 2 roots and both the roots are negative. So if both the roots are negative, can I say both the roots may be equal, may not be equal? Yes. So starting off with the case of equal, I am taking two roots as equal. So I know that minus two negatives and two positives together can give me what? Equal roots also and unequal roots also. At the same time, both the roots may be equal to a 0, which is just like saying both the roots being equal and coincident roots. So how many cases for equal roots will I get? One case wherein both the roots are the same and have negative polarity. Another case wherein both the roots are same and having positive polarity. Third case, both the roots are neutral integers being equal to a 0. And how many cases for unequal? Okay, so can I say that two roots of opposite polarities will always be unequal? Two roots of opposite polarities will always be unequal. So which am I talking about? Are these of opposite polarities? Yes, one case, another case, third case, fourth case. And at the same time, two roots which are equal but they are having opposite polarities. So how many cases have we formed? So if you count the number of cases, we have got 9 cases. I'll repeat. We have formed 9 cases of equal and unequal roots based on their polarity and then combined it with their magnitudes. Magnitude is the value. For example, the magnitude here is x and x. Same here. The magnitude here is x and y. What is the magnitude when you're not talking about the polarity? So we started the discussion with polarity, ended the discussion on polarity and magnitude both. This discussion can be taken further also. So that means, is this the end of it? No, it is never an end of a topic. Right? For further discussions, when we start putting the questions as discussed in the last video also, we'll be giving you a link in the description, which is the link for our website, which will give you all possible questions either in this video or in other videos that we would have put up till date. It may also, it may also have questions which we may not have given in any video as well. Right? If you think that today's video gave you a fresh perspective or a different perspective towards quadratic equation which nobody else have given you till date, please do not forget to like, share and subscribe to our channel. If you have already done so, please click on the bell icon, select the all button so that you start receiving updates regularly. Yeah. Thank you so much. Until next time we meet. Goodbye.